Thank you for inviting me today. It's been actually an interesting journey for me because I'll explain in my presentation, but this is a new kind of area of work of analysis for myself and my team. So I'm actually just going to go through that story and that journey of where we are with this data and give you a kind of an inkling of the data at the end, but I'm not going to give you any actual firm figures because I'm not quite sure the figures are actually correct yet. So, which is might sound like I'm ducking out of it, but there's good reasons why we need lots of checks on the data. So this is very preliminary, and I was actually only just finished doing all of this half an hour before the meeting tonight. So I'm just going to give you an overview of the source of the prescribing data and then the results of the analysis. So just to explain how prescribing in primary care works for those of you that don't work in primary care and how we get access to the prescription data. You have a doctor prescribing on a computer, that creates a prescription, that goes to a pharmacy, but when they prescribe on a computer, it also sends a message to a centralized computer. And so it creates an electronic message as well as a paper prescription. When the pharmacist is given the prescription, they use the barcode to pull that information down. They dispense the medicine. Information is sent back to the central computer, and information ends up in the central depository of data. If this electronic system doesn't work for whatever reason, if the electronic system doesn't work and it is a computer-generated prescription, we're actually still odds on for collecting the KI number from the prescription because there's a scanning process here as well. So as long as the KI number's on the script somewhere and it's done printed, then there's a good chance we're going to capture the KI. What happens when you don't use a computer? So you have a doctor who's handwriting a prescription. The script goes to a pharmacy dispenses it, and then there's a person who looks at that script and takes the information off that prescription and puts it into the database. That person is employed to take information off the script that's sufficient to pay the pharmacy contractor. They're not paid to take any additional information. The other thing, the reason why we don't capture KI from these scripts here, is the doctor probably might not be so inclined to actually write the KI number on. So there are issues around particularly handwritten prescriptions that can be of relevance to this area of prescribing. That information is collected and ends up in a system or is data that's equivalent to what we would call PRISMS data, which is why we've got PRISMS up there. And why KI is interesting and going to be really helpful for us analysing prescribing is for two reasons. And if we have KI, if KI is on every single prescription that is dispensed to you across your lifetime, by the end of you slipping off this mortal coil, the NHS will have a record of every single prescription, every single medicine that was dispensed to you by primary care. So we have this longitudinal information about your exposure to medicines in your lifetime. The other way that KIs are helpful is that we can use KI to look at certain areas of prescribing, certain groups of prescribing, and then capture information on what type of people have prescribed particular drugs, which is what we're going to move into with this analysis. But the issue around KI is the capture of KI off the prescriptions. So these are quite busy graphs, but there's not really much to them. Basically, before I started analysing the data and started to count patient numbers, I went to the scripts to find out how well the KI was being captured off those scripts. And what this is all the opioids by drug name, and you can see that for the majority of opioids, the KI capture rate is quite high. It's well over 95%, particularly by the end of the middle of this year, June to August this year. These stragglers, I can't remember if it's stalagmites or what's. Thank you. They're very, very infrequently prescribed opioids that end up on handwritten scripts and stuff like that. So you don't really have to worry about it. The bulk of the prescribing of opioids is in this group here. and there are a couple of stragglers. And the same for hypnotics and anxiolytics. These stragglers here are things like chloral hydrate and very unusual, very uncommonly prescribed drugs, which explains why they end up not capturing the CHI, because they end up on half the time on handwritten scripts. Gabapentin and pregabalin, interesting. You don't have an obscure drug within pregabalin and gabapentin. There are only the two, and the option of brand prescribing or generic prescribing. But CHI capture rate is incredibly good for both drugs, up to 99%. So if we're analysing if we wanted to count the number of patients prescribed pregabalin and gabapentin, we could easily go to this PIS database and use that to count patient numbers. And we'd be reasonably confident the number we got out was pretty much bang on the actual numbers being in the community. This is the problem for this analysis. The red line is methadone, the blue line is Suboxone. Only 1 in 4 scripts are we capturing the CHI off. So the next slide has the big health warning on it that the numbers I'm going to tell you or quote to you probably are an underestimate. Added to that is is the fact that my team have only just got given this data, have only been recently given this data, so we are still finding our own feet around how to best manipulate the data, how to best analyse it and count it. And even within the process of doing this analysis and doing this report, I'm going to be writing a report for the MCN. I've had to go back and redo the whole analysis 2 or 3 times, because I've been doing little quirky things like double counting, duplicate CHIs and things like that. So here's the result. Got no information on it, no data, because I'm not that confident of the information, but it does give you a feeling of the proportions. So if we go into the data set and look for the number of patients who have been prescribed methadone or Suboxone, there's around 9,000 in Greater Glasgow and Clyde. So that bubble is 9,000 people. If we then look at the prescribing of opioids to those people, and this is a very wide definition of opioids. This includes the cocodamol 3500s, codigamol, Remedine, kind of the stronger codigamol. Then of those, 910 of the people treated for addiction are also prescribed an opioid in a broader sense. Of those, only 72 are prescribed a strong opioid. But I was just having a conversation to Katrina that actually defining particular drug names as being strong opioids in this area of care might actually be a mistake, because there are lots of people who are taking lots of moderate opioids but in high quantities and in combination. So the person that's on cocodamol plus tramadol, they may end up being on quite a high equivalent dose of opioid. But anyway, in this analysis, this is what would be termed, in the BNF, would be termed strong opioids. So there's 72 of them. And if you look at the people that are prescribed methadone and Suboxone, and then look at whether they're given a hypnotic or an anxiolytic, 405 of them are given, 2,257 are given a hypnotic and anxiolytic, about a quarter. And if we look at gabapentin, then 523 are given gabapentin. And I have positioned those circles as pretty much accurately as I can to make sure that all the vectors work. I didn't have a specialized software. I actually did this by hand, shoving the circles around. But in effect, that group of people in there that are getting all 4, so they're on a strong opioid, so they're being prescribed methadone or Suboxone, they've got a strong opioid, they've got pregabalin or gabapentin, and they've got a hypnotic and anxiolytic. There's 21 of them. So that's less than 0.23% of the population. And I can go through the numbers of the other bits and sectors in there. So that was really it. I didn't want to, I can't say any more just yet. We will be doing a lot more QAing on the data to make sure that it's accurate. There are complications around doing this analysis, which are interesting for us, because we would normally just analyse prescribing within a particular practice. So you look at an individual prescribing to a patient who is within a practice. The interesting thing about this group of patients is they're prescribed by lots of different parts of the organisation. So actually we've got to deconstruct the whole analysis and start getting rid of any reference to which practice they're attached to at any period of time, and actually just say, across Glasgow, where are they getting the drugs? And later on we might be able to unpick where they actually got prescribed from. But in the first instance, we've got to get rid of all of that to then do this kind of analysis. So these patients being treated for addiction, it doesn't matter whether they're in a GP practice or not, and whether they're getting these other drugs, it's actually where they got this drug anywhere in Greater Glasgow and Clyde by any part of the organisation, not necessarily the same person that prescribed the methadone and the Suboxone. Does that make sense? That's quite an important distinction, particularly if you are going to look at the data yourself.